Hi guys, today we'll be solving the May 19th challenge. The question is longest increasing path in a matrix. So this one we will be given with the matrix and we have to find out what is the longest path which is having a strictly increasing number. So if you see this, one is from 1 we can go to 2 because 2 is greater than 1, and from 2 we can go to 6 because 6 is greater than 2. That way we can traverse wherever we see a increasing path. So let's see how we can solve this. Today for this one I have taken the same example here and I will be solving it using DFS. And you can also solve using dynamic programming, but I'll be using DFS recursive solution. So let's see how we will be solving. To start with, I'll be writing two for loops. In this two for loops, we will be going over each and every cell, starting from here till every cell we will be traversing in our main function. In each cell, we will try to run a DFS call from here. So let us start from here. So from this is my first cell. From here, I will try to run my DFS. What this DFS will return is DFS will return the length from this cell. If we start, what will be the length that will be returned by the DFS. So I will call from here. From here we will try to move to the next cell here, but the condition is not satisfying. These both are equal. It should be increasing, only then we'll be able to move to the next cell. So this will return 0 to this this call. It will return 0 to this call. Okay, from here we got a 0, and I will try calling this cell. From here also I will get a 0 because we cannot move forward, and I will try to move to the top and I will try to move to the this one, but they are out of bound. This will also, let's say they are also zeros, and now what is the maximum I got from the neighbors, that I will be adding with 1 and I will be keeping it as my value. So my value for this cell, the output was 1. Okay, that I will be storing it in a hash map or a cache or a dictionary, anything. So that will be stored here. If I come again to this cell and ask what is the length if I travel from here, then we can directly return 1. So that's why I am storing it in here. Okay, then our for loop will continue. Here we will be calling the next cell. From here the same logic. I will try to go to this one. I'll try to go to this cell. I'll try to go to this cell. I'll try to go to this cell. Everything is less than this cell. So everything will return 0 to this cell. Then I will add 1 to it and I will store it. From this cell, if I start, my length will be 1. Same thing I will do with this one. This will ask this one. This is a correct condition. So what this will do, if it does not have any values to return, then it will also recursively call every cells. But we already have stored and kept what will be the length if we start from this cell. So that value it will return to the caller. So call 4 will get 1 from this one. And 4 will try to ask 8. 8 is a new cell. It does not have any values, return value stored. So it will try to call every other cells like this. It will try to call this one also. Why I am not using visited array is because this condition will only handle since 8 is greater than 4, so this call will be not valid, and also this call is out of bound, it is not valid. And this call since 1 is lesser than 8, this is also not valid, and since 6 is lesser than 8, this is also not valid. From every direction it got zeros. So we will pick the maximum value which it got and we will add 1 and we will store it here. Okay, now for 4 it called 8. So for 4 we will return the value 1 to 4. So 4 will pick up what is the maximum it received from every calls. So the maximum it received was 1. So it will add 1 to 1 and it will store 2 as the result. So here what it is means, if I start from this cell, then the maximum length I can go is 2. So similarly we will be checking here. So this will call this, this will call this, and this will call this, and this will call this. From every direction we will get zeros because 2 is lesser than 6 and 6 is lesser than 6. Only here, from here we already have a result 1, and this is greater than 6. So this will return this 1 to this 6, and we will add 1 to that, and we will store the value here. Okay, similarly here, from here it will try to call this, this will return 0. I'll try to call this, this will return 1 to us, and I will try to call this, this will also return 1 to me, and I will try to call this, this will return 0 since 1 is less than 6, and I will add 1 to the maximum value that I received, and I will store it. This is 2. And from here I will try to call this, this will return 2 to me, and I will try to call this, this will return 0 to me because this is less, and the maximum I received is 2. So I will add 1 to the 2, and I will store the value as 3 to my result. And from 1 I will try to call all 4 directions, and all 4 directions, this direction will return me 2, and this direction will return me 3, and I will add 1 to the maximum value, and I will store it. And similarly here also this will return 0 to this, and this will return 1 to 0 to 1 to this. So maximum is 1. So I will store 1 plus 1 2. So if you see this, what is the maximum value that we so far received? That is 4. So that is our answer. So 4 is our answer. So let us try to solve this question now in DFS. So I'll get into the code. I'm using Python. So first we will write a DFS function. So we will, to keep track of the result, we will keep have one variable result, and in our for loop we will, as I told, so we have to find out what is the row and columns. So we have given with the maximum. Let us find out the length and fill these values. So length of first row will give us number of columns, and see we have all the metadata. Now let us run 2 for loops. In this 2 for loops we will try to call our DFS function. We'll try to call our DFS function with I and j. Okay, then this DFS function, whatever it is returning, we will store it in result. Then we will try to maintain the maximum of the already existing result, comma whatever DFS function is returning us. Then we will finally return our result. Okay, so now let us implement our DFS function. So our DFS function is, it will take 2 parameters I and j. Our I and j will always be valid. Now what I will do, I will temporary for our result, I will maintain initialize my result to 0. Finally we have to see all 4 directions, right? So I will write a for loop for that. For difference I and difference j in. So if we have to go to all 4 directions, then we have to go to minus our current direction with 0 and -1, this stuff. So it will go to the left column, and this will go to the top row, and this will go to the, so I'm just adding this values to this I will be adding this values so that I will be able to move to the top, left, right and down. So just I will write these things. So these all combinations we will be trying to add to our D to get a new I and a new J. So I'll be adding all I plus difference I'll add to this, and j plus difference j I will add to this. So now I got all the new index where all I can reach from the current index I and j. Now let us check if this is valid. If I is less than 0, that is a boundary, and j is less than 0, that's also a boundary, or I is greater than equal to n, that is also a boundary, or j is greater than equal to m. So we don't have m and n inside our this, so let's get it. M and n. Okay, they are outside, so we are getting it inside, and this is the condition where we are checking for the maximum increasing. Okay, so here we will check our matrix of the new elements, that is new I and new j should be greater than whatever currently we have, but if it is lesser than or equal to, then we need not continue. Lesser than or equal to the parent elements I and j, so we need not continue. Okay, so I'll say continue, don't continue forward, just continue to the next loop. Now we will call our DFS function. Now we will call our DFS function with the new I and j. Okay, now whatever this is returning to us, we will maintain its max in our result. Okay, now we got our results from all 4 direction, then we will return whatever result we got from all 4 direction plus 1, that's our current node. So this way we will be able to find out the result in a recursive way. Okay, let us try to run this, if we have any bugs or not. Okay, here list index out of range. So I am just checking for I and j. I have to check for new I and new j, whichever I got. I'll just replace all the values. So let us try to run now. Maximum recursive depth. So what I will be doing is, I have to store these values in these places, right? So I will, for storing them, I will use cache. Okay, then it will store all those values. There's one mistake here, so I have to call with new I and new j, that's why it's going to maximum recursive depth. Yeah, now it is working, guys. So now I'll try to submit this code. It got submitted successfully. Thanks for checking in my videos. I'll see you in the next video. Thanks for watching. Bye.